It is 3 minutes past 10, so let us start. We cannot wait for everyone. I have something to say about the assignment that I gave you. Achom Martha? Achom? Achom, what is allotropy? Achom, are you there? Don't know where she is. So, the question that I had given you asking to explain why graphite conducts electricity, whereas diamond does not. The way you answered it is not the way I wanted you to answer. Many of you are just saying, that that diamond. Many of you are just saying that diamond does not have mobile electrons, whereas graphite has mobile electrons. That is correct, and it is true, but you are not going to get all the marks. You are not going to get all the marks. The best answer for us to give is you give a reason why in diamond there are no mobile electrons. So can you get a pen and a book and you note the reason that I'm going to tell you? And we saw it from the structure of diamond, whereby I told you that in diamond, so we are going to say that in diamond, each carbon atom is bonded to 4 other carbon atoms. In diamond, each carbon atom is bonded to 4 other carbon atoms by covalent bonds. In diamond, each carbon atom is bonded to 4 other carbon atoms by covalent bonds. And therefore, all the electrons in diamond participate in bonding. I repeat the statement we are noting down and saying, in diamond, each carbon atom is bonded to 4 other carbon atoms by covalent bonds, and therefore all the electrons participate in bonding, and therefore all the electrons participating in bonding. However, in graphite, all electrons participate in bonding, therefore diamond does not have mobile electrons. That's the reason. So when you are told to explain, for you actually you gave a reason, you did not explain. So there are 2 questions which can be said. Someone can tell you, give a reason why diamond does not conduct electricity. There you are free to say diamond does not have mobile electrons. That one will be okay. But also someone can say, explain why diamond does not conduct electricity. That means now you are maturing in chemistry, you senior twos. When someone says explain, it means give a reason and explain your reason. Okay? And we are explaining that by saying in diamond, each carbon atom is bonded to 4 other carbon atoms by covalent bonds. Therefore, all electrons participate in bonding. And that's why in diamond there are no free what? In diamond there are no free electrons to conduct electricity. However, we said in the structure of graphite. So we are now going to graphite. We are going to say, however, in graphite, each carbon atom, the thing is here, each carbon atom is bonded to 3 other carbon atoms. In graphite, each carbon atom is bonded to 3 other carbon atoms by covalent bonds. You know, a covalent bond is formed by sharing of electrons. So if one carbon atom is bonded to 3 other carbon atoms, that means that that carbon atom is using 4 electrons, is sharing 4 electrons. Eh? Yet they are supposed to be 4. Okay? That means 1 electron out of the 4 is left not bonding. And that is the thing. Okay? So in graphite, each carbon atom is bonded to 3 other carbon atoms. In graphite, each carbon atom is bonded to 3 other carbon atoms by covalent bonds. And therefore, 1 electron does not participate in bonding. 1 electron does not participate in bonding. Therefore, graphite has mobile electrons. Okay, any question about the reason that we are looking at? Then the uses of diamond and graphite, we looked at them. Today, you people, I don't know how to tell you how important that is. Allotropes of carbon. Last time, we saw that there are crystalline allotropes and amorphous allotropes. Crystalline allotropes of carbon are only 2, that is diamond and graphite. Today, I don't know how to tell you how important this is. Today we are going to look at amorphous forms of carbon. Amorphous forms of carbon. The word amorphous means non-crystalline. It is in solid state, but it is not crystalline. It is solid state, but not what? Crystalline. So amorphous carbon is black, very black. Actually, I've never seen anything that is as black as amorphous carbon. That's why sometimes I don't know what you are talking about when I hear some of you saying your friends are black. People say we are black Africans. No, our color is not black, my dear. You don't know what black is. A black color. Someone cannot say that your skin is black. Something black is, I don't know. So amorphous carbon is very, very black. Now you can look at the charcoal that you use for cooking. That is amorphous carbon. Amorphous carbon is black and has the lowest density. So you know, if you compare crystals and the amorphous form of carbon, crystalline carbon has a very high density. Eh? Now the statement is here. It is non-crystalline and fairly conducts electricity. Amorphous carbon exists in several forms like wood charcoal, animal charcoal, sugar charcoal, lamp black, and coke. Now your role in this is very simple. For each form of carbon, ensure that you know its use. Those are the questions we ask. For every form of carbon that is here, ensure that you know its use. Anytime we can ask you. Let us begin with wood charcoal. Wood charcoal, this is the one that you use at home. The charcoal that comes from wood. Okay? Wood charcoal is the one that you use at home. So what is the use of wood charcoal? This wood charcoal, number one, the important use everyone should give us is it can be used as fuel. Don't say it is used for cooking. We shall cross you. I repeat, don't say it is used for cooking. Your answer should now be mature. It is used as fuel. Wood charcoal can be used as fuel. Now, it is formed when wood is heated in limited supply of air. That means if you heat that in excess air, even the charcoal is going to continue burning and it will form ash. That's why we say it is formed when wood is heated in limited what? In limited supply of air. Destructive distillation of wood. This is destructive distillation of wood. It is a black porous solid and a very good absorbent of gases. So let us write it. Let us now note down somewhere there, because I will ask you uses of wood charcoal. Number one, it is used as fuel. Number two, I don't know. For me, I have it here. There is when sometimes you feel you have some gas in your stomach. Actually, if you go to the village, our grandmothers, for them, they just get that charcoal which you use for cooking, they put in their mouth, and they swallow, as if they are eating food. But there is this advanced charcoal tablets. Yes, in hospitals, even in clinics, they are there. Their role, ask your parents, they should have ever used them. For if you have never, ask your parents. And I know some of you, your relatives are doctors, nurses. Ask them. They will tell you about charcoal tablets and its role. So you see, they move with chemistry. Ask them. Actually, this was one time a question in UNEB, and people failed it. They were saying it is used for cooking, and we crossed. We said give one use of charcoal other than being used as fuel. So that's the answer we wanted. The answer is it is used to make charcoal tablets, or someone can say it is used to absorb poisonous gases in the stomach. It is used to absorb poisonous gases from the stomach. That is wood charcoal. Uses, I've told you, it is used as fuel, then it is used to absorb poisonous gases in the stomach. Now, one form of amorphous carbon is done, and it is wood charcoal. Let us now go to what we call animal charcoal. We have two. We have wood charcoal and animal charcoal. Don't confuse especially their uses. You should not confuse. So animal charcoal is made by heating. So for animal charcoal, you know, animal, the word animal comes from heating animal refuse and bones in limited supply of oxygen. It is formed by heating animal refuse and bones. So you just put animal bones in limited supply of oxygen. Now, the most important use of animal charcoal, if I ask you for use of animal charcoal, it is the only use that you should give. The most important use of animal charcoal, we took you to, I remember we took you to Jinja, no, to Kachira, in the sugar factory. That is the most important use of sugar, I mean of charcoal. You know, if you are very observant, there is white sugar, and then there is this sugar which has a color of yellow. That sugar with the color of yellow is not very pure. And I think that's what most of you take at home. The white sugar, for it, is obtained by using animal charcoal. So you add animal charcoal to the yellow sugar. So the role of animal charcoal is to absorb or to remove the coloring matter. The use is here. It is absorbing coloring matter and is used. So the use starts from here. It is used to remove brown color from sugar during its manufacture. People, I hope you are noting. The use of animal charcoal, is used to remove color from sugar. It is used to remove brown color from sugar during its manufacture. That is the reason why there is white sugar. That's the reason why there is white sugar, and that white sugar is the one that we call sucrose. Ask the biology teacher. That white sugar, pure white sugar, is the one we call sucrose. In fact, if you go to our lab, you'll never see a tin that where we have written sugar. For us in chemistry, we put there sucrose, but we know that is sugar, pure sugar. And that white sugar is obtained by using animal charcoal. So animal charcoal removes the color from sugar during its manufacture. Let us go to sugar charcoal. Now that white sugar that is obtained by using animal charcoal, that white sugar, it also contains carbon. So from that white sugar, we can get sugar charcoal. How do we do that? Now, sugar charcoal, we are saying this is a very pure form of carbon made by removing elements of water from sugar. So when you remove elements of water from sugar, you remain with sugar charcoal. And how is that done? We saw that sulfuric acid, concentrated sulfuric acid, is hygroscopic. Hygroscopic means, who can tell me the meaning of the word hygroscopic? Hygroscopy, I want the answer. What is hygroscopy? Is someone telling
The
me?
process,
Yes.
yes,
Mm.
process of removing water from the atmosphere.
Hygroscopy is removing what?
Water from the atmosphere.
You don't remove. there is a word we use. Hygroscopy is the process by which substances absorb water from the atmosphere. So when we are saying concentrated sulfuric acid is hygroscopic, it means it absorbs water from the atmosphere. So in this case, we use it to absorb water from sugar. And when that is done, you remain with black substance called carbon. And that black substance formed is sugar charcoal. Okay? Is sugar charcoal. So this sugar charcoal can also be used as fuel. Can also be used as fuel. So sugar charcoal is obtained when the other white sugar is dehydrated, or the word to dehydrate means to remove water, is dehydrated by concentrated sulfuric acid. Let us go to lamp black. Lamp black. Lamp black, I told you the other time. How many of you have ever used a paraffin lamp? At least if you have grown in urban centers, if you have grown up in Kampala, ask your parents later on. There is this lamp that uses paraffin and it has some glass on top. So when you use that paraffin lamp for some time, you'll find that the glass, after like a week, is covered by some black substance. That black substance is like soot. That black substance is called lamp black. It is called lamp black. Even if you are using a candle, a tadoba, you will see soot being formed on top of the flame. If that soot was collected, it is also called lamp black. Lamp black. And that soot is an amorphous form of carbon. What is the use of that? This lamp black has many uses. Now, all of you at school, we only want black shoes, and you all come with polish, shoe polish, black, black. That shoe polish you come with, it is made from lamp black. So note down uses of lamp black. It is used to make shoe polish. And how is it obtained? It is obtained by burning oils. Kerosene is paraffin, petroleum, etc. Even when you are seeing a car and from the exhaust there is a black fume coming out, you know that one is also lamp black. It is used for making shoe polish, and it is used for making ink. It is used for making printing ink. Then another use, it is used. Do you know carbon papers? Amera, do you know a carbon paper?
No.
When you want to remain with a copy, let us say receipt books, there is that black piece of paper. It is like polythene they put behind the paper, so that when they write on top, what they have written remains goes on the other page. Come on, you have ever seen that? How many of you, if you know a carbon paper, tell me. How many know a carbon paper? Raymond, where did you see a carbon paper?
Former school.
Former school?
From the office.
So, what was its color? Black?
Black and ink behind.
And ink behind, eh? So that carbon paper is also made from lamp black. So uses of lamp black, we are saying it is used to make shoe polish, used for making ink, and used printing ink, and used for making carbon papers. The last amorphous form of carbon is coke, and coke is the most impure form of carbon. It is made by heating coal in absence of air, and it is used as a reducing agent in extraction of iron. That is the most important use of coke. It is used as a reducing agent in the extraction of iron. So the allotropes of carbon, we are done, but we are also saying coke can be used as fuel. But you should not only rely on fuel, because like I told you, sometimes when we ask a question about about the use of carbon, we may say give the use of carbon, or I mean of coke, other than fuel. Give the use of wood charcoal other than fuel. Other than fuel. So that means you should be knowing something like two uses. Chemical properties of carbon. How does carbon react in oxygen? I expect all of us to be remembering this. Do you remember in senior one when I told you that when carbon burns in oxygen, it can burn under two situations? Number one, oxygen may be in excess, and number two, oxygen may be limited. Oxygen may be in excess and oxygen may be limited. In excess oxygen, now let me find out. Immaculate, someone tell me what is the product when carbon burns in excess oxygen, and what is the product when carbon burns in limited oxygen? Duku, Glory, Immaculate, Joy, Karen Plays, Melissa, give me the answer. Harry?
When carbon burns in presence of limited oxygen, it forms carbon monoxide, but when in presence of excess supply of oxygen, it forms carbon dioxide.
Very good. Do you know how to write equations, Duku?
Yes.
Wow. Okay, thanks a lot. What she has said is very correct. Carbon in excess oxygen, please note this equation. In excess oxygen or in plenty of oxygen, carbon burns to form carbon monoxide. And you should always remember this, that there is also sodium, which forms one product in excess oxygen and another product in limited oxygen. These substances you should know. So in excess oxygen, the product for carbon is carbon dioxide, and in limited oxygen, the product is carbon monoxide. Now, this equation here, we don't encourage you to balance with the fractions in O level. So since this is a half, you can multiply every atom by 2, so that you put 2 on carbon and you put 2 on carbon monoxide. So that's what we should do. There will be a 2 on carbon, then 1 on oxygen, and then a 2 on carbon monoxide. Reaction of carbon in deep, brightly glowing coke. This is also a very common question. Very, very common. Now, this question is testing. Where does carbon burn completely? And where doesn't carbon burn completely? So in region A, look at region A. This is a very common question. We draw for you the diagram and we ask the question. In region A, a plenty of air is available because the air is entering from these holes down. Is available. So carbon burns to form carbon monoxide. That is in region A. But in region B, ascending carbon dioxide is reduced by red hot coke to form carbon monoxide. The word ascending means from the bottom to the top. So this carbon dioxide that is formed here, as it goes up to region B, it is reduced by coke to form carbon monoxide. And this is our carbon monoxide in region B. At the surface we mean here at the top, the hot carbon monoxide burns in air to form carbon dioxide, and carbon burns with a blue flame. So we have 3 regions and 3 cases. Take note of that. At the bottom here, where air is entering here, carbon burns completely because there is plenty of air. Carbon burns completely to form carbon dioxide. Then as that carbon dioxide ascends up or goes up, it reacts with coke. It is reduced by red hot coke. Remember, coke is also a form of carbon. That's why on the equation we are saying carbon dioxide plus carbon, you get carbon monoxide. Now, on top at the surface, this carbon monoxide that has been formed will also react or will also burn in excess oxygen at the surface because the chimney is open to form carbon dioxide. Let us look at reaction of metal oxides with carbon. Now, metal oxides, carbon is a reducing agent. Who can tell me one gas that we looked at that is a reducing agent? One example of a gas that is a reducing agent that would play the same role as carbon here to reduce the metal oxides to their pure metals.
Hydrogen.
Hydrogen, good. Hydrogen reduces these 3 metals to their pure metal. I mean these 3 metal oxides to their pure metals. So if it was hydrogen, we would form zinc plus water. And now since it is carbon, we shall form lead, metal, and carbon dioxide. So in this case, we say that carbon reduces, let me use this equation. In this case, I will say that carbon reduces copper 2 oxide to copper and is itself oxidized to carbon dioxide. So carbon reduces copper 2 oxide to copper and is itself oxidized to carbon dioxide. Reaction with acids, carbon reduces nitric acid and sulfuric acid to nitrogen dioxide and sulfur dioxide gases respectively, and the equations are here. They stand as they are. Carbon reacts with nitric acid and sulfuric acid, but the condition is these 2 acids must be concentrated. Keep remembering that. So for nitric acid, we form nitrogen dioxide, carbon dioxide, and water. Then for sulfuric acid, we form sulfur dioxide, carbon dioxide gas, and water. And then reaction with steam. Remember, we said carbon does not react with water, but it reacts with steam. Steam is blown through red hot charcoal, and a mixture of carbon monoxide and hydrogen is formed. And this is called water gas. Water what? Gas. When steam is blown through a mixture of, when steam is blown through red hot charcoal, a mixture of carbon monoxide and hydrogen is formed. So water gas from today, note it down there. Water gas is a mixture of carbon monoxide and hydrogen. And this is the equation. Water should be in gaseous state. Water gas is a mixture of carbon monoxide and hydrogen. So I don't want to give you very many things